Hello everyone, you're welcome to my YouTube channel, Messed Up Mentors. This is Python for All, PY4A. Today we'll look at Object-Oriented Programming, Part 3. Here we will discuss multiple inheritance and method order resolution, known as MRO, Method Resolution Order, I mean to say. In today's video, we will dive more deep into the Python super built-in function, which allows us to extend the functionality of a parent class in a sub-class. And so the Python super built-in is very useful by a subclass when extending the method or methods of the parent class or the inherited class. Let's start with a simple example. Here I have a class of points and I've defined the constructor and it takes two arguments, x and y, which is the coordinate of a point. And so here I have the instance x and y, okay? And then I have also a REPR method, the rep method, which is just to print human readable and also debuggable string representation. Okay, so what the rep method here does is same thing as what the str method or the string method. So it enables you to print, human readable format of whatever you have passed it to return, and then gives us that flexibility also debug the code. So that's what I have here. So what I'm printing exactly is to return the coordinate of x, comma, y. So we run this, we have it as a namespace. Then I can define a point P1 and then pass in the argument x equals 2 and y equals 5. Let's print P1 and see what it returns to us. When you call print on P1, you actually invoke this ROEPR method. So let's do that. If you call that, you see it prints 2, comma 5. And if you look into our ROAPR method here, we're simply asking it to print the coordinate of x, comma y. Next, let's check the method resolution order of the point class. So you print and call the class name, okay, and then you pass in dot the Donda method MRO. If you do that, it tells you that you have a main class of point, okay, and okay, it has already inherited from the base class of object in Python. So that's the method resolution order. Next, let's look at another point. In this case, I want to implement a second point, this time around a polar point, and this point you inherit from the class point. And then the polar point takes in to input argument, the radius, and the angle. But because we are inheriting from point, and remember point has two named arguments, it means that we have to call, the super method and initialize the two input arguments. It has to be what x and y. Okay, you can name it anything, but it has to take two input arguments. So to do that, we need to convert the radius and the angle to get x and y. And you know fully well from the polar conversion from the polar coordinate to the Cartesian coordinate is defined this way because we need the trigonometric cosine and sine of the angle. We have to import this library math, and so I have x equals r math cos. So I didn't instantiate x and y. The reason is because I'm directly not calling any other method in polar point, but rather passing them as input argument to the super. What super does is that super helps us to avoid explicit call of the inherited class or the parent class. In previous Python 2.7 and less than Python 3, we call point dot and then double underscore init and passing that. So by doing this, only instantiate was self dot theta. What we have, if we run this code, we have it in a polar namespace rather, and then we can define polar equals polar point, the radius and the angle. Let's print polar point. If we print polar point, you will see what happens here. We're going to have the rep method, which you have defined in the point class, okay, being put to use. Why? Because by inheriting the point class and calling this super, we automatically also inherited all the method in the parent class. So let's see that. We run this. See, it returns what now? Returns the x comma y coordinate. In other words, here the polar point class is simply what are converting polar coordinate to Cartesian coordinate. Okay, if we print the method resolution order, okay, of polar point, what do we have? It returns what? It returns um, instead of printing, I can still call it whichever way is same result, whether you print it or you call it this way. It returns, main or polar point, point, and object. Okay, so let's print it. Yeah, run again, returns class of polar point, telling that polar point, okay, inherits from what? The point of class, and class inherits from the base class of objects in Python. Okay. Now, let's look at the second example here. In this second example, I want to demonstrate a class of lines. So I first of all I need a package numpy because I'm going to handle some array manipulation. So I have a class of line. Of course, a line is defined by the intercept, okay, plus the first parameter, the first coefficient c1 times x, or y equals y equals c plus mx, okay, something like that. So this is the definition of a line here. And so I define my constructor passing the two parameters. They are constants, but they change, okay, depending on the particular line you're dealing with. And then I invoke another method here, which I call call. I've defined this in my previous video when I talked about functions. Especially when I also dealt with decorators, okay, and closures. There, I told you the call method there specifically returns this line, okay, and allows you to make a function call on it for it to behave like a function. So in the call method, it takes in value x, okay, which will always output the line, and then returns self.c0 plus self.c1 multiplied by x, which is the definition of this line. And then I have another method I've implemented here, which is table. The method table simply prints, I just loop through a set of points, okay, between an interval, and then return a table of it. That's what this table is. So first of all, it prints a table of x and y. Okay, this file of the uh, backward slash t here is just to give it means a tab, to create a tab space, and then I loop through for x in range linspace. This is the interval L and R, like the left interval, the right interval, and then the number of points you have, we want between interval. You now can see here I'm making a call to what now? To this line. I just say y equals self of x. This self of x, oh, 1 second, just a minute. Just a minute. This self of x, what it does is that it simply calls this line via this call method, and then we can now print x and y. Let's see the output when we run this code. Here we run, we have the namespace. Let me call the line of L1 equals line of 2, comma 3, C0, C0 is 2, and C1 is 3. Okay, and then we take line of 4. Here, we're simply saying that x equals 4, right? That's what we're saying here. So if we run this code, what we have, of course, 3 by 4 is 12 plus 2, 14. If you print y is 14. Now we can as well call L1.table, and then we'll pass in the left is 2, the right is 10, and we want 10 points, right? If we run this again, it returns a table of x, x and y, where x is the input and y is the output based on the constants 2, 3. Now, we can decide to have another class now, which I call a class of parabola that inherits from line. So I then because inherit from line, then I will instantiate the parabola class. Of course, it takes two parameters, C0, C1, and a third one, which is what now? C2, right? So I will instantiate self.c2 to be C2, and here I can call self.line equals line of C0, C0, C1. Here I'm making a call to the line. Okay, there are other ways of doing this. Okay, we can actually use super here, but there are other ways of doing it. But first of all, let's make this call. Okay, I have self of line, and then I define a call method. And what would I return? Self dot line of x plus self dot c2 multiplied by x squared. Because the line of the for parabola, the equation of the parabola is simply something like this. Let me call it p. Will give us c naught plus c1 multiplied by x plus c2 multiplied by x or squared. Something like this. That was the parabola line. The equation of the parabola looks like, right? So that's what I've made in this call. Be mindful I've not implemented the table method, but because I've inherited from line, the table method is automatically inherited into parabola class. So we run this and then print parabola of 1, minus 1, and 2. And then, of course, I can print the name, class name. If I run this, it returns parabola, right? I want to check the method resolution order. What will it return? It returns parabola, line, and object. Okay, if I want to get the basis, okay, the base classes, if I run p double underscore class double underscore dot double underscore basis double underscore, what will it return? The base class is what is line. And then if I want to print p dot table between 2 and 6, an interval of 10 points, what do I have? It returns the table value. So that's one way. The alternative way of doing this, which is the most elegant way of doing it, is calling super. So here you define the init method and then you call super.init. You pass in C0 and C1 because that's what it takes instead of line.init, right? And then we define C2. Then under the call method, remember here we were calling line and adding this. Under the call method, we just call super dot call x. That automatically calls this method in the line, the call method in line, and then you add the self dot x square. So if we run this again, what do we have? And then repeat the same with parabola. We have this, and then parabola dot table returns this same table. So this second method is actually the method I prefer because it's the most elegant method of doing it in Python. And this can give a lot of flexibility when you have multiple inheritances. So what's the visual representation for what we have? And that's where I will end the video for today. I don't want it to be longer than 15 minutes. So the visual representation is just this. We have a class of line that takes an init, a call, a table, C0 and C1. While in parabola, we have the init, the call method, and it inherits from line. Therefore, the table method is actually not implemented, but inherited from line, and then you pass in parameters C0, C1, and C2. This is just a short descriptive illustration of inheritance, okay, and method resolution order in Python, okay, while implementing classes. If you have any question, please leave it in the comment section. Like this video, share this video, and if you're watching and you have not subscribed to my YouTube channel, please do subscribe, okay? And when you subscribe, do not forget to click the notification bell to get notified of my new upload. I will see you in my next video, Object-Oriented Programming Part 4, where I will continue with example 3 and dive more into other concepts. Bye and see you in my next video.